Okay, all one of you watching my live stream. It started. Here we are. Gonna solder a board that I've titled Epoch. Let me take a sip. Daddy needs to be lubricated. Solder. All right. Let's move this out of the way. I got my bill of materials. It tells me what to put where. So resistors, all those things. So I printed that out and put that somewhere. I'll find it later. Then the board is this. This is the Epoch board. Oh my goodness, it's hard to adjust for camera angle here, but there you go. All right. So what is the Epoch, right? All right. So this board brings together a Adafruit Huzzah, which has a ESP32 module on it, battery charger, and it's like a little feather shield thing. Really great development platform for doing Arduino type stuff. It has Bluetooth built in. So a lot of good features and a little $20 circuit board. We have a LCD screen, a little color 320 by 240 color LCD screen. Its interface is a SPI, so very simple way from the ESP32 to access it and draw graphics on the screen. Again, Adafruit makes a very nice graphics library for it, so it makes my development work easier. All I have to do is just draw squares or fonts or things to it. So I thought that was a nice thing to have. The third component on Epoch is it drives, where are we at here? Oh, this little chip, this tiny little chip package is a 16-channel pulse width modulation controller. And what that means is over the SPI signal, again, this SPI bus, the serial peripheral interface, you can talk to this chip and then toggle in 16 channels worth of 12-bit, I believe, level PWM control. So you can lock a channel in, and then it handles the toggling of this this pulse width modulation or duty cycle for a channel, and you can tell it to be 0% duty cycle or 100% or 50%. And then it just handles that for you, and at a guaranteed current amount of current being put into the thing you're driving. The chip is made for video walls, for driving current into really bright LEDs, and some of those LEDs can be 100 or 120 milliamps. But the chip lets you like fine control how much current goes through the LED. And so for video walls, you want to calibrate color and brightness and all that. So that chip handles all that. I found this chip for 100 milliamps, 120 milliamps is great for driving really small vibrators. And do I have a dead one here? If I can find it. Oh my goodness, what do I do with it? Where's my stuff? Hold on, I got a bag. Let me show you these. Got the new ones here. So these are tiny little vibrators. They're the kind you'd find in a pager or your phone or some other device that just buzzes really low. They burn about 100 milliamps at 3 volts, so perfect for my project. And I wanted to control up to 16 of them in a programmatic way through a touchscreen device. So the Epoch board was born, and so that's what it drives. At the bottom here, these are for Molex connectors, and there's 4 channels of motors per connector. So if I just want 4 motors, I plug in 1 connector, run that off to a harness of wires that could do the 4 motors. So that's what that does. And there's some little capacitors here that help provide instantaneous current to the motors. And those will be something I'll solder on last. The top side of the board is the direction the Molexes go into. Here we go. In the center, there's a power switch to tell the computer to turn on and off. There's a header connector here for the LCD, and then the Huzzah module sits here. And then one of the things, I had a couple pins left, so I pinned out a SD card, a micro SD card connector. It's kind of optional. I don't really have a use for it yet, but it's there. And if I want to like store images or data or some other logging, that might be a thing, is what was put out, and just have a log of it and be able to look at it later. So I have a way of storing some files onto a little thing. So I have that connector there too. I don't think I'll be soldering that today. I can't. I got to go look through my collection and find that connector. I have a couple left, but it's not necessary. So let's get down to soldering. What was the other part of the show and tell? Oh yeah, so like Epoch, for me to, before I did this board, I tested out that functionally with code and the ESP32 I could like talk to the LCD, I could talk to the PWM, and everything was kind of copacetic. So I made on a breadboard. These are the components. Maybe this is not the best place for this. I think I can zoom out a little bit here. There we go. All right. So I have a ESP32 there in the corner. That's what's going on the PC board. I wired it up to a this LCD. This is a little 3-inch LCD. Runs over SPI color, 320 by 240. Bought it on Amazon to like 15 bucks. And then it has the touchscreen built in, so I can do that stuff. And then this is a little shield I made a few years ago, which has the PWM chip on it. And this was an experimental shield that let me do the same 16 channels and stuff. And it was a project I had like put away and didn't think I was going to really do anything with. And then the idea for Epoch came, so that was that's where I'm at with that. So that's what I have, a prototype and all wired together. It works through code. So I was confident if I made a PC board, it wouldn't be garbage. If I wouldn't miss any wires or anything because everything's there. So so there's the board. So let's get zoomed back in here. There we go. And then I'm gonna solder this, or start soldering this up. Sorry if it's blurry. It's like, how close is your camera? Does it focus? Zoom, all that stuff. So I apologize. I don't have a high quality iPhone enough, I guess, for macro stuff. But you get the point. I don't know if zooming out would help at all. Just make it look better. Okay. There's that. Let me check the chat real quick, see if I have any anybody asking me anything. Nope. All right. All these things to do. Okay. Let's start soldering. My setup is I don't know if you can see it. So there's my microscope. I have a soldering iron behind that. So that's my desk that I'm doing. And then hopefully I can get my microscope in here without bumping my cameras and things and lighting. Good here. Oh yeah. Okay. Let's just start with the chip, since that's the fun part. I got my foil bag from Mauser Electronics. Gotta open it up. Should be a chip inside of there. So let's get that unsealed. Oh yeah. Alright, so there's a bag in a bag. Let's cut you open. Comes with a little moisture dot thing that tells you if it's pink, that's bad. Got to dry your parts out, but I'm not too worried about that as a hobbyist. So here's my little, I bought 2 of these chips. They come in a little, they snip it off of what looks like a film reel with thousands of parts on it, but if you only buy 2, they snip them off and leave them in the little container there. So let's get that out of there. Let's pop the chip out. Here's our chip. Throw this back in the bag. Throw the silica gel back in. And then put it in its label bag so I know what it is later. That's gone. Done. Alright. So this chip, let's see this chip. That's the chip. The bottom matches the circuit board pattern. You can see that. So it's got little pins on the edge, on the outside edge, and then it's got a pad for heat sinking and sometimes ground in the middle. So let me get this down. There's a dot on my board. I don't know if you can see the dot in the corner of the chip. I put in my marking, and that tells me to put the dot. There's a tiny dot on the chip. Line those up so that you don't have your chip oriented wrong. So here I see a tiny little dot. So that's going to go there, right on the board. And so let's add a little solder. So you can put this on with solder paste. I'm going to solder it with solder. That's how I do it. But you can do like a solder paste and get it all squishy in there, and you reflow or heat the whole thing, heat the whole circuit board, and it'll all melt. It'll all gel together. And so I'm going to use a little combination of both. So to get it started, I'm going to add a little bit of solder to the center pad, and then I'm going to add some solder. I'm going to solder some of the edge pins down to anchor it. I'm going to throw a bunch of flux in there, and then run the heat gun over it. And then what that'll do is kind of that's the reflow part. But I'm not using paste. I'm using hard solder, and I'm just kind of tacking things in. And then I'll inspect it to get all the pins what they need to be. So let's get the center first. So can I zoom in anymore for your kids? Oh yeah, there we go. So sorry it's blurry, but like better than nothing, right? So let's scoop this off. So I'm going to put a little bit of solder right in the center pad. There, that's way more than enough. So that's actually too much. So what I'm gonna do is get my solder wick and take some of that solder off. I just want enough to get the pad of the chip to touch that. But it's too much. It'll lift the chip up off of everything, and then the other solder pads won't really connect. So I'm just gonna remove. There we go. Just a nice thin coating. Solder. There. I'm just trying to get it level enough so that the chip won't be too wonky when it sits down. There we go. That's probably good. Put a little solder on the pads. And I'm just gonna kind of set it there and tack it in place, and then we'll use heat. So let's just get a couple of pads here. A little bit of solder, and again take a little bit off the middle again. I want it to be like a little just too much. All right. There we go. I think that's good. Right, probably good. I'm gonna position the chip on here. Line up my dot. I'm going to get I'm going to tack it down just to anchor it so that it's positioned where it needs to be, and then when I reflow it, it won't have to move or go anywhere. A lot of times a reflow doesn't actually make a chip move at all. So I'm just working with one edge, but I'm trying to heat it. Like it's stuck now, but I'm trying to heat it so I can kind of get it more aligned the way I want it to be. But you have to get all the pins heated, and then it'll scoot just a touch. Okay, that's almost where I want it. Come on, little buddy, you can do it. Wait. Here we go. It's probably close enough. Take a look at the edge here. Exact. So I can just bump this a little more, and then I'll finish heating it. I think it's aligned enough on the pad that when I go to heat it, it doesn't have to like move too far. It won't bridge over or do something weird. So I think that's good enough for that. So now what I'm gonna do is get my flux. I just cleaned my bench, so now I don't know what I did with my flux. This is why I don't clean things. It's underneath something. Here we go. All right. So I have this stuff called rosin flux. I think I bought this on Amazon. It's just flux in a jar. It looks like bad honey. Don't eat it. But it looks like just kind of disgusting looking. But when it heats up, it turns into this sauce that allows metal, the lead or whatever your solder is, just allows it to flow, lowers the surface tension on things, and then surface mount stuff tends to solder better and look shinier when it's done when you flux it. And then you use alcohol to flush all of this off after you've assembled your board. So I am going to apply. I'm going to dip in here with my tweezers, a little clump of it. Where am I? There. And then I'm going to just kind of, like I'm icing a little cake here. Just going to get a little bit on every surface. Just get it underneath there, and so there, that's plenty, and it's going to smoke when I heat flow it. So that's the only other thing, is make sure you have a fan nearby, which I don't. I had to unplug my fan because it was going to interfere with the microphone. So it's going to get a little bit icky in here for a touch, but whatever. I need something to wipe my tweezers with here. All right, that's that away. So one way to do this, I think, is tinfoil. Let me see if I'll be right back. I got to get a little tiny piece of tinfoil. If I don't have some in the trash here, which I don't think I do. All right, I'll be right back. I'm back. I got tinfoil. Not for a hat. Okay, so to keep me from melting my silicone pad. It says silicone, but I've melted these before. So I'm gonna put this on the surface, put my board back down, and then I'm gonna reflow the chip, and we'll see how we do here. And then for the reflow operation, I have this heat gun. It puts out like 800 degrees or whatever it is at the tip. It gets very hot very fast. It's a tiny, quiet little reflow thing. Ungar model 6966. So if you're interested, but I've had this for like 20-30 years now. It just works. It does the job. So let's reflow the chip, and you'll probably see it smoke. But I'm going to reflow this, look for the solder to melt, kind of like position itself. As long as it all settles mostly, then I'll finish the pins again with an extra approach at soldering. So let's do this. You can see the flux melting already. And then just going to stay on it for a second. Alright, the smoke. Okay, let's see what we got here. Yeah, when I'm reflowing, I'm basically looking for it to get hot enough where the solder melts, and that flux, which lowered the surface tension, the chip will, like, if it's off just by a little bit, it'll like snap. It'll snap into place till you'll see the chip just kind of either move or just shift. Or you'll see the solder twinkling, and then you'll just know it's melty. So, and then don't bump it while it's cooling, and just let it sit for a minute. It's like really freaking hot. So I'm just gonna let it sit here for a minute, and then I'm gonna inspect it, and if I didn't screw it up, it'll be fine. What I found is most chips can take a lot of abuse from heat and reflow again. LEDs cannot. LEDs are very sensitive, especially those the newer ones you get with the RGB ones, the WS2812, 2811, those are like, you look at them with heat wrong and they just die on you. So but chips themselves, for whatever reason, they're packaged differently. I've cooked chips way too long and they're fine. So something to note. And so same thing, LEDs don't like being washed in alcohol as much, especially some of those programmable ones. So I usually do LEDs last in my assembly, and I don't wash the board at that point. So if there's just little dots of flux, no big deal. But for the chips and resistors and stuff, everybody gets whatever they need, as much heat as they need to get it done right. So, all right, I think enough time has passed here. I can get rid of my tinfoil. Let's inspect this under my scope and just see how did I do. Is it still aligned? Is whatever I melted? Yep, most pins have solder on them. I just have to go back and do the edge pins again. But the pad underneath, the hidden pad, is the one where I'm worried that did I? Sorry, I lost the where we're at. There we go. So the can't. So I'm just looking under the scope to see if these little pins have like soldered correctly, and I'll clean that up. But the pad underneath has to get melty enough to, like, you know, connect the thing on the chip to the pad on the board, and then the rest of it's just you can correct the pins at the edge under a microscope. So it looks like I'm probably okay. So I'm just going to inspect each pin here. Sorry, you can't get my hand in there. But it looks like the pads line up pretty much perfectly. So now I just got to go in there with the soldering iron again. There's flux in there already, and a little bit of extra solder, and just make sure each pin has enough solder. It's hard to show here with this setup, but if you look under the microscope, you'll see a pin doesn't have any whatever solder was there wicked away somewhere else. So we just gotta visually correct all of these, and we'll be fine. So here. All right, that's good. Okay. The big complicated chip is done. So we're just going to go down the bill of materials. Let's get you back over here. Lining this up is kind of a pain. Here we go. All right. I'm going to get you a good camera angle. Setting this up is a little bit wonky. But whatever. There we go. I'm going to do the. I'm just going to go down the bill of materials now. So I did what I think is kind of the hard part. And then just go down the bill of materials. I have 2 small capacitors, C1 and C2, 0.1 microfarads. Here we got a stack here. Here's one of the other things I'll do a show and tell or a talk about on my Patreon later. Is I made these 3D printed, I'll show them up here. These are cartridges, so they have my capacitor in there. What type of capacitor? These are from reels. You can see through there. There's the capacitor tape. I bought reels years ago at a surplus store. They're like $1 a reel, and a reel of caps were at the time were like $30. So bargain. So I bought as much as I could that made sense of common values. So I 3D printed these cassette cases. I did them up in Fusion, and then I just designed the two pieces of gray plastic and orange plastic. Orange is for my caps. So, oh, here we go. Slide this open. So it's a carrier printed in gray. I coiled up as much of the parts I could fit in there, and then I have a little feeder out the top, and then I 3D printed these covers and I embossed them with the what they are, capacitor or whatever, and then added like some labeling to finish them off, and then I put the the edges so that when they're in like a bookshelf style I can go find them again. So that's where I get my parts from. I have all my parts organized now in like little containers. So I just need 2 of these. I'm going to put them right on the board, or right out on the surface. So let's get 1. Get out there. There you go. 2. Got 2 little tiny grains of salt. That's those 2. Let's prime some pads with some solder so I can anchor them down and find out where they go. So let's see here. Wow, lining this camera up is a little weird. Alright, there we go. Hopefully I don't block this with my hand. I'm going to go find my cap locations. Alright, so I got a bunch of parts to put down on this board. I'm just going to prime these right now. Okay. And then let's put the cap down. C1 and C2. Where'd C1 go? Right, there's C1. Put this camera somewhere where it's easier for you to see without me getting in the way. That's probably fine. Alright, so I put solder on one side of the pad for the capacitor and then anchored it down. And then I'm going to go find the other capacitor, which is over here next to this connector. I can zoom in again. No, there we go. I need a cameraman. I need a crew, right? Yeah, I'm just sorry. Apologize for the blurriness. I don't know. I have another USB camera I can try out next time. See if that does a better job. But I thought the iPhone would be fine, but it doesn't do macro at all. So where'd my part go? Oh, there he is. Sorry. Come over here. So let's get you. Here we go. All right. Alright, that's my capacitors. I have a 330 ohm resistor. Let's get that one. And there's only one of them, so let's just pop that out onto the thing. So, I saw you go. This is R1, I believe. Oops. All right, I got R2, 100, R2 and R5 are 100K. So let's get a couple of those. One, two. R2. Yeah. Right, and then R5 was the other 100K. Put it on the board somewhere. It's there somewhere. There you go. All right. Oops. R5. We have a single 1K. The 1K is R3. Okay. And then I have two 10Ks, R4 and R6. Okay, 1, 2. R6. Just remember, that's on the other side. It was. No, it's on this side. Where do we put it? Where are you at? A resistor. There we are. All right. I'll be right back. I'm hearing really strange noises outside of my house. I think it's wind, but I don't know. I'm getting invaded. Sorry for that interruption. It is wind, 40 miles an hour today, blowing stuff around outside, so the oddest sounds you'll ever hear. All right, I did my 10Ks. Got most of the parts done here. We have a PFET. Let's find our PFET. Okay. A little transistor. Put that guy in. There we go. You can see that. Same thing like the chip. Little tape, like 8mm film from the old times. They use it in automation when they do high-speed assembly. These machines pull these parts off of these film reels. Alright, now let's see, where do you go? Over here. Let's get you on camera. Oh my goodness. Alright. That's nice. Try to get this part flipped over. They are, and they're sometimes when they're like a turtle on its back, they're almost impossible to get flipped over with just tweezers. But I got it. All right. Let me get this positioned. All right, that one's down. I believe that's most of the parts. I think I just have fuses now. Yeah, just fuses and then big parts, which I'll do one or two of those and then end this stream. I don't want to bore everybody to death, right? So let's get these little poly fuses in here. Got them somewhere in the stack. There we go. All right. So let's see. There's two values of fuse. I have 100 milliamps. And then the 750. Okay, so let's do the 100 first. The 100 milliamp fuse is F LED. F LED. So let's do you. Alright, 100 milliamp fuse. So again, it comes in a little reel. It's going to peel the tape. And drop it down. Alright. Let's see, where's it at here? There we go. There we go. Put a little bit of anchor solder on there. Get you positioned, and this is F LED. Another one. Yeah, and these parts are like different values, but they're identical except for their little marking, and then the marking isn't the number, it's just some code they put on there. So you just have to be careful when you do these to note what's what. All right. Those are down. Let's tack. Let's get all the other sides. So I only soldered one side of each component. Now I'm going to do all the other sides, and then everybody will be down on the board. And you're able to see that? Yes. All right. Here. There. All right, that's all the surface mount parts for this board. That part was at least somewhat simple. I just lied. I have those giant, I say giant in surface mount terms, capacitors. So let me find my source for those. Where do they place those? Here we go. All right. So let's get those down. And then I'll basically throw in probably one of the Molex connectors, and I'll show you how a header goes in. But that'll be the end of the stream. So we're almost there. I don't want to bore you to death. So here's my tape for this same thing. Old capacitors. These capacitors are old. I had them in my stash, and they're old capacitors used to be huge. But this type of value tends to be pricey because of their value. 22 microfarads in a small ceramic package. But I had some. I didn't have to go buy new ones. I guess I need 8 of these, not 4. Let's get 8 of these. 1, 2, 3, 4. Okay. Yeah, these particular caps, they're special. I used to work at Sun Microsystems, made computers up until 2009, I think. Got bought by Oracle, but and that's about when I left, not by choice. But when they cleaned out one of the storerooms, one of the people there was like, "Do you want all the junk in the storeroom?" And the storeroom had all the little parts, bags of 20 parts we'd buy, and so. She's like, stop on by and load your car up with as many components as you want because we're throwing them out. And so I loaded up, but this bag is labeled This is how they got labeled. They were sample parts for a project, so they got a Sun part number, and maybe a manufacturer's part number, which I try to look these up and I never find any. But I think the Sun number's at the bottom. There's a different part at the top. It looks like there were maybe 71 in here, and there was 38 left when they threw them out. And these say 47 microfarads, which is bigger than what I need for the project. Probably not a bad deal. So that's a lot of my parts I have are like 20 or 30 of these random parts, and a lot of times I have to figure out what they are because they're not marked. They're marked with old Sun part numbers, which I can't look up. So that's a lot of my collection. I just have stuff that's like from places, but every now and then I get stuff that has, you know, enough of a marking I can like I can kind of sleuth it out and then reuse some of these parts. But it's good to save a little money, right? But yeah, some of these parts are like 30 years old because that's how long ago I got them. But they get used. So let's get all the caps lined up here. Alright, finish the edge. And we'll get into a connector. Right. I'm going to hit the back side again just so no cold solder joints, no extra solder. I've never done this particular Molex before. Let's see if I got the hole sizes and position right. Because I've done connectors where I get the circuit board in and it's like, that doesn't fit. Alright, get my Molex in a bag. Loose parts. I do love Molex. I've been using Molex for like 30 years since I started as an engineer, and Molex has a lot of great connectors. I just love the brand. I'm going to just do one right now. Like the the series. They have a series called Mini Fit Junior, and it happens to be the pins. If you've ever put together your own PC, that big power supply cable with the 24 wires on it, that is a Molex Mini Fit Junior. It's a very popular connector. Easy to get wires and parts because you can take them out of old PC power supplies and get extra parts out of them. But it's one of my favorite connectors for doing power. This is called a NanoFit, which is the little smaller version of that. But it's still for power, a lot of current, and a tiny little, I'm going to get this up here, and a tiny little connector. But you can do some pretty boss stuff with this stuff. Let's see, can I get this? Is this a good angle for soldering? It fits. While I was talking to you, it just went right in. So you can see right here, it's sat down, sits flat, right to the edge of my board. I'm going to solder those pins right there. But that's basically, it did what I wanted it to do. It looks like I read the instructions from their drawing, and because I make my own parts in Eagle. I don't trust anybody's parts anymore. I've been burned so many times, so I take an extra 3 hours and I'll read a chip spec or a connector spec, and I will make my own component, and I'll get the 3D model. Usually they have at least the 3D model, and pair that in and verify it and stuff, but that takes extra time. But once I have it, then I use it again on another project. It fits. But I've been burned by other people's supposedly connectors, and then you find out it's just like doesn't match, or the part number doesn't match, or this doesn't match. So I don't use anybody's pre-done library anymore. I make my own, and then if it's wrong, I can only curse at myself. Grumpy old engineer, right? Am I getting this on camera? Where are we at here? You're here. Okay, yes. So let's get that soldered in. Soldering here. All right, I think that's enough solder. So there's at least one connector on the board. I'll add the power switch last. The Huzzah module I'll do later, because that needs to be a certain height off the board, and I need a little finesse for that. Then right here is a header connector, which is for the LCD, and then the LCD can come off when I need it to come off. So let's see if I have any in my little connector dish. Do I have any connectors? And I can wrap the stream. So looks like I maybe have that, right? So this is the connector I'm going to put in here. So the pins on the LCD will just plug into this. So let's, I'm going to have to shorten this connector down because this is the length I have. So I'm going to pull a pin out of here. Just make sure I pull the right pin. So here. Pull this pin out of the connector. There. So that got yanked out. Now it looks like a missing tooth. And then we're just going to cut the connector in half right there. So let's get this right there, I think that's where I'm going to cut that. Yep, pretty soft plastic. So you can see just shortened this down to a 14 pin. I could clean this up. I don't have to. Nothing's gonna like hit. So let's put this on top here. So that's in the board, and we'll solder that in. A little bit of something to support my board here. Right. So the trick with headers to get them straight is you solder exactly one pin, and then you straighten the connector or do it on a jig. I have made jigs for this. Like if I have many connectors, I'll make a jig that takes all the pins, and then when you put the board in, everything's like 90 degrees lined up, perfect. So I soldered in just one pin, and you can see how it's there we go. It's cockeyed. So a lot of connectors, if you just heat them up and just press with your finger, you'll feel them go flat. So that's what I'm going to do here on this one. So I'm going to just solder the one pin, and then I can kind of feel it go flat. Is it flat? Nope. See? Feel it, but it didn't quite go. So now I can just kind of use my eye. Sorry, I can't line up the camera and that and all at the same time, but there we go. Flat enough. So that's that now, and it's flat down on the board. There's no gaps. No gaps that way. Maybe a little. What do we think? No, it's down. All right. And we just finished soldering this connector. So I think with this, I'm going to end up wrapping up the podcast. If you like, support me on my Patreon so I can buy more parts and build more things. My higher level tier has this Epoch project in it because it talks about what it's used for. Which are vibrators. And so I'm going to talk more about that in that tier, but it's like, sorry, it's locked behind all that, but there's be some of this I'll make in my public tier when I can talk about it. But all the other work I've been doing, CAD, Fusion 360, CAD, 3D printing, how this all fits into like a little iPod-sized device, touchscreen development, that's all going to be there. And then some of it I'll leak out to the free tier. But I have lower tiers in my Patreon for other things, gardening, other electronics things that I do. My next, I have a basic tier, but the next tier up is for things like swag. So every now and then I'll make a PC board that you might want to use, and then I'll give for free a PC board to my upper tier subscribers. Stickers, anything else I create. I do artwork stuff sometimes. So if you are generous, please feel free to join my Patreon. You can always just follow in Patreon without paying any money, and I don't mind. A lot of my all my GitHub stuff is free, so find my GitHub through my Patreon link. All my projects I've been working on, mostly Java lately, games, random dumb stuff, Raspberry Pi with Java effects. So whatever my brain is at, it's all there. You can just go check it out and review it, try it out. I have a lot of half-done games that don't work, but if you are interested in the concept of it, definitely contact me and just pick my brain if you want. So I think with that, I'm going to end this stream. Thank you for watching me solder my Epoch board together, and there'll be more in the future of demoing the working system once I get some code running. So stay tuned, sign up to my YouTube channel, follow me on Patreon, follow me on GitHub, follow me on Mastodon, Maehem on Mastodon.